All right, today we're going to crack open the engine of the internet itself. We're taking a 30-year journey to really understand HTTP, the basic language of the web. We're going to see how it went from this super simple tool for grabbing text files to the high-speed foundation for, well, pretty much everything you do online.
You totally know this feeling, right? You click a link and boom, the page is just there, instantly. Then you click another one and you're just staring at that little loading spinner thinking about anything else? Well, that difference, that feeling of speed versus slowness, it's not magic. It's actually the result of decades of some seriously brilliant engineering solving one problem after another.
So, to really get how we got here, we've got to rewind all the way back to the beginning, back to 1991. This is when the web was just kind of learning to talk, and its vocabulary was, let's just say, extremely simple.
The very first version, HTTP/0.9, was as basic as you can possibly imagine. It was really designed for just one thing: get me a text document. That's it. But as the web started to grow, that just wasn't enough. So along came HTTP/1.0, and it added crucial context, basically metadata, in these things called headers. Suddenly, your browser and the server could share information about the request. Then came HTTP/1.1, which introduced a real game changer: persistent connections. This kept the communication line open instead of hanging up and dialing back for every single file.
And you can really see that huge jump in complexity right here. On the left, HTTP/0.9 is just barking a command: get this document. But look at the right. HTTP/1.0 is having a conversation. It's not just asking for the document, it's also saying, hey, by the way, I'm this kind of browser, and I really prefer this as an HTML file. This was a massive leap forward.
Okay, so the protocol is getting smarter, right? But here's the catch: websites were getting way more complicated. Those simple text pages from the early 90s, they were being replaced by these rich, interactive experiences, and that created a brand new, massive problem.
Just think about this number for a second: 70. That means to load just one average web page today, your browser has to go out and make 70 separate requests. 70! It's got to grab the main document, all the style sheets, all the little scripts, every single image. Yeah, the old protocol just wasn't built to handle that kind of load.
And this right here, this is where we hit the web's first huge traffic jam. It's called head-of-line blocking. The easiest way to picture this is a single-lane highway. You could have 100 super-fast sports cars, but if there's one slow car at the very front of the line, guess what? Everyone's stuck. On the web, one slow-loading image could bring the entire web page to a grinding halt.
So what do you do with a massive traffic jam? Well, the smartest folks on the internet got to work trying to turn that single-lane dirt road into a multi-lane superhighway.
Now, HTTP/1.1 tried. It really did. Its persistent connections were a clever patch. It was kind of like getting rid of a bunch of toll booths on that highway. It definitely helped. But, and this is a big but, it was still just one single lane. If one request got stuck, everything behind it just had to sit there and wait. Gridlock.
And then, HTTP/2 comes along with an absolutely brilliant solution: stream multiplexing. Instead of sending one whole file, then the next, and the next, HTTP/2 chops everything up, every image, every script, into these tiny little pieces called frames. Then it sends them all at once, all mixed together over one connection. This is our multi-lane superhighway. Now, if one little piece of an image gets delayed, who cares? The other pieces from other files can just zoom right past it in their own lanes.
And this really gets to the heart of it, This whole process was never about adding bells and whistles just for the sake of it. Every single one of these big updates to HTTP was laser-focused on one thing and one thing only: speed, making the web experience faster for you.
So, HTTP/2 was a revolution. It felt like the traffic jam was finally solved. But as the engineers started to really push the limits, they found a deeper problem. The problem wasn't the cars anymore. It was the road itself, the very pavement the highway was built on.
Here's the thing. Even with all those new lanes in HTTP/2, the fundamental system that managed the whole connection, a protocol called TCP, it still saw everything as one single stream of traffic. So if just one tiny little packet of data got lost along the way, TCP would slam on the brakes for everybody to go find it. The superhighway was there, but it was built on a really shaky foundation.
And what you're seeing here, this might be the most radical change in the entire history of the web. Seriously.
On the left, you see HTTP/1 and HTTP/2 are both sitting on top of that old foundation TCP. But with HTTP/3 on the right, they just ripped out the entire foundation. Gone. They replaced it with a brand new protocol called QUIC. It was literally like tearing up the entire highway system and starting over from scratch.
So what the heck is QUIC? Well, think of it this way. The old foundation, TCP, was like a super cautious delivery driver. It checks every single package is in perfect order before moving on. It's reliable for sure, but it can be really slow. QUIC is built on a different system that's all about speed first. Then it adds the reliability back on top, but in a much, much smarter way. And the crucial thing is, each of those lanes on our superhighway is now truly independent. A lost packet in one lane has zero effect on any of the others.
And here's the real-world magic, the payoff for all that work: way faster initial connections. And this incredible thing called connection migration. You've definitely experienced this, right? You're on a video call, you walk out of your house, your phone switches from Wi-Fi to 5G, and the call doesn't even stutter. That's QUIC. It lets you hop between networks seamlessly, something that was a total nightmare with the old TCP system.
Okay, so we've gone on a pretty deep dive here. From single-lane roads to multi-lane superhighways built on a brand new foundation. But what does all of this technical stuff actually mean for you just using the web every day? Remember that feeling we talked about at the very start? That difference between a website that just snaps onto your screen and one that crawls? This is why. This whole 30-year journey is the reason pages load in a flash, why your video streams so smoothly, and why complex web apps can feel just as responsive as the software on your actual computer. It's the invisible, relentless engine that powers our modern digital lives. When you look back, the story of HTTP has always been about solving today's problems to build tomorrow's web. But the web never, ever stops changing. So it really makes you wonder, right? With everything that's coming, AI, virtual reality, an even more connected world, what's the next big traffic jam that HTTP is going to have to solve?